By 2025 and 2026, about 88% of organizations report using artificial intelligence in at least one business function, according to the McKinsey Company Global Artificial Intelligence Survey. However, only about 6% of companies report achieving large-scale measurable business value. Many firms experiment with artificial intelligence tools in marketing, customer service, and operations, but transformation remains limited. This shows that adoption is rising faster than real economic. Research from McKinsey Company shows that nearly 80% of companies using generative artificial intelligence report little or no significant financial improvement. Organizations are deploying chatbots, automation tools, and predictive systems, yet measurable revenue growth remains unclear. The gap between expectations and real results highlights how media excitement often moves faster than practical enterprise integration and operational change. According to research shared by Gartner, only a small portion of artificial intelligence projects move beyond experimentation into real business transformation. Many organizations launch artificial intelligence initiatives without strong data infrastructure or clear operational goals. As a result, projects stall or deliver minimal impact. This demonstrates that technological capability alone does not guarantee successful implementation or measurable business outcomes. Reports from Gartner indicate that a large percentage of artificial intelligence pilot projects never reach full production. Companies frequently test artificial intelligence models in controlled environments, but struggle to deploy them across real workflows. Data quality problems, integration complexity, and operational costs often slow deployment. This reality contrasts with public narratives suggesting rapid and universal artificial intelligence transformation. A benchmarking report from Accenture explains that most organizations expect artificial intelligence investments to take more than 2 years before producing clear financial returns. Despite strong executive enthusiasm, real productivity improvements require workflow redesign and employee training. Artificial intelligence adoption is therefore gradual, not immediate, showing that business transformation takes longer than media headlines suggest. The International Monetary Fund reports that artificial intelligence could affect nearly 40% of jobs worldwide, increasing productivity while also reshaping business structures. However, the report also warns that economic gains depend heavily on infrastructure, education, and regulation. Many companies expect rapid profit growth from artificial intelligence, yet structural adjustments across industries will take years before consistent financial impact appears. According to the World Economic Forum, artificial intelligence is improving task-level productivity across finance, marketing, and logistics. Yet most organizations are only automating small processes rather than transforming entire business models. The report emphasizes that true transformation requires organizational redesign and workforce reskilling, not just software deployment. This explains why measurable performance gains remain uneven across industries. The Artificial Intelligence Index published by Stanford University shows that data quality remains one of the biggest barriers to enterprise artificial intelligence success. Many companies adopt advanced models but lack structured and reliable datasets. Without strong data pipelines, predictions become inconsistent and difficult to scale. This technical limitation slows real-world deployment despite increasing global investment in artificial intelligence tools. Financial analysis from Goldman Sachs estimates that global artificial intelligence investment could approach hundreds of billions of dollars within this decade. Despite this surge, the report notes that many organizations are still experimenting rather than generating stable revenue growth. Capital spending is accelerating faster than operational returns, showing how market expectations often move ahead of practical implementation. Enterprise research from Microsoft indicates that employees are rapidly adopting generative artificial intelligence assistants for writing, analysis, and automation. However, many organizations still lack formal governance policies and structured workflows for these tools. As a result, productivity improvements vary widely. Adoption at the employee level is moving faster than organizational transformation, reinforcing the gap between excitement and measurable business outcomes. A global survey by IBM found that more than 75% of executives believe artificial intelligence will provide competitive advantage. However, only a small portion report fully operational artificial intelligence systems across core business processes. Many deployments remain experimental or limited to internal tools. This gap shows how strategic optimism often exceeds real operational maturity. According to the World Economic Forum Future of Jobs report, nearly 44% of worker skills are expected to change due to artificial intelligence and automation. Yet companies report difficulty finding employees with data and artificial intelligence expertise. Without skilled teams, organizations struggle to scale projects, delaying measurable business outcomes despite strong investment trends. Research from McKinsey & Company shows that generative artificial intelligence adoption doubled between 2023 and 2025 across multiple industries. Marketing, software development, and customer service lead usage. However, most companies report improvements in efficiency rather than direct revenue growth. This indicates that early benefits are operational, while long-term financial impact remains uncertain. The Artificial Intelligence Index report by Stanford University explains that most enterprise artificial intelligence systems currently automate narrow tasks such as document processing or prediction analysis. Full automation of complex workflows remains limited. Businesses often overestimate how quickly artificial intelligence can replace decision-heavy processes, creating a gap between public perception and technical reality. Industry analysis from Deloitte highlights that infrastructure costs, including computing hardware and data storage, remain a major barrier to scaling artificial intelligence systems. Training advanced models requires significant investment, which delays return on investment for many organizations. While headlines emphasize rapid artificial intelligence expansion, financial constraints continue to slow large-scale deployment. Forecasts from Goldman Sachs estimate that artificial intelligence could increase global economic output by trillions of dollars over the next decade. However, the report also explains that productivity gains will appear gradually as businesses restructure operations. Many organizations expect immediate financial impact, but historical technology shifts show that transformation typically unfolds over long implementation cycles. According to data published by Organization for Economic Cooperation and Development, private investment in artificial intelligence continues to rise globally, especially in software and automation sectors. Yet the same research shows that large-scale deployment remains concentrated in a limited number of industries. This imbalance highlights how investment excitement is expanding faster than practical adoption. Research from Stanford University and Massachusetts Institute of Technology shows that artificial intelligence tools can improve worker productivity in controlled environments, particularly in writing and coding tasks. However, results vary widely across real businesses due to workflow complexity and data limitations. Experimental success does not always translate into consistent enterprise performance. A global executive study by PwC reports that many companies adopt artificial intelligence partly due to fear of falling behind competitors. This competitive pressure often accelerates experimentation before infrastructure is ready. As a result, organizations announce artificial intelligence initiatives publicly even when internal deployment remains incomplete or limited in scope. Policy analysis from the European Commission shows that artificial intelligence regulation is expanding to address safety, transparency, and data protection. While businesses promote rapid innovation, compliance requirements are increasing operational complexity. Governance frameworks slow uncontrolled deployment, demonstrating that real-world artificial intelligence adoption must balance innovation with accountability and legal standards. Analysis from Reuters Institute for the Study of Journalism shows that technology reporting frequently emphasizes disruption and risk to attract audience attention. Artificial intelligence coverage often highlights extreme scenarios such as total job replacement. However, enterprise reports continue to show gradual automation of specific tasks rather than complete workforce replacement across industries. Data from the International Labour Organization indicates that most artificial intelligence adoption affects task structures instead of eliminating entire occupations. The research explains that automation typically reshapes job roles rather than removing them completely. This contrasts with popular media headlines predicting rapid large-scale unemployment caused by artificial intelligence systems. Research published by Stanford University highlights that generative artificial intelligence systems still produce factual errors and inconsistent outputs. These reliability limitations prevent many organizations from fully automating critical decision processes. While headlines often describe artificial intelligence as fully autonomous, enterprise deployment still requires human verification and supervision. A technology leadership survey by Deloitte shows that many companies publicly announce artificial intelligence strategies before operational integration is complete. Organizations use strategic communication to signal innovation to investors and markets. However, internal deployment frequently remains in testing phases, reinforcing the difference between external messaging and real system integration. Industry research from Gartner indicates that artificial intelligence chat systems are widely adopted in customer service, yet most still require human escalation for complex interactions. Automation improves response speed but does not fully replace human support. This demonstrates that artificial intelligence enhances workflows rather than completely replacing service operations. Research from McKinsey & Company shows that about 60% of occupations have at least 30% of tasks that can be automated. However, very few occupations can be fully automated because business processes involve judgment, coordination, and context. This demonstrates that artificial intelligence changes task structures rather than completely replacing entire professional roles. A technical analysis by IBM explains that artificial intelligence performs best in prediction-based environments using structured data. Complex decision-making that requires ethical reasoning, incomplete information, or human negotiation still depends heavily on human oversight. This gap highlights why enterprise artificial intelligence deployment often focuses on assistance rather than full automation. According to enterprise risk research from PwC, data privacy and cybersecurity remain major barriers to scaling artificial intelligence systems. Organizations worry about sensitive information exposure when using large artificial intelligence models. These risks slow deployment and require governance frameworks, contrasting with public narratives suggesting rapid and unrestricted adoption. Industry infrastructure reports from NVIDIA indicate that demand for high-performance computing hardware continues to exceed supply. Training and deploying advanced artificial intelligence systems require specialized processors and large energy resources. Infrastructure limitations delay enterprise scaling and show that technological expansion depends heavily on physical computing capacity. Energy analysis from the International Energy Agency reports that data centers supporting artificial intelligence workloads are increasing electricity consumption globally. While artificial intelligence promises efficiency improvements, infrastructure growth introduces new energy challenges. This reveals a practical constraint often overlooked in public discussions focused only on technological capability. In one strategy meeting, executives discussed artificial intelligence adoption after seeing competitors announce breakthroughs. Teams at Microsoft, Amazon, and Google were constantly cited as examples of rapid innovation. Yet internally, managers admitted most tools still required human review. The excitement felt real, but so did the uncertainty. It became clear that artificial intelligence was influencing decisions faster than it was transforming operations. At a mid-sized software company, developers began testing artificial intelligence coding assistants inspired by tools released by Microsoft and OpenAI. Early results looked impressive during demonstrations, with faster code generation and rapid prototyping. However, over time, engineers noticed that reviewing and correcting generated outputs still required strong expertise. Artificial intelligence accelerated drafts, but responsibility for accuracy remained human. A digital marketing team modeled its strategy around case studies from Meta Platforms and Google, expecting artificial intelligence to fully automate campaign creation. While automated tools improved audience targeting and content suggestions, creative direction still depended on human judgment. Campaign performance improved gradually rather than dramatically, showing that artificial intelligence enhanced decisions instead of replacing strategic thinking. Customer service managers adopted chatbot systems inspired by automation frameworks used by Amazon. Initial reports suggested artificial intelligence would handle most conversations. In practice, simple requests were resolved quickly, but complex cases continued to require human agents. Teams realized artificial intelligence reduced workload pressure rather than eliminating roles, shifting employees toward problem-solving tasks instead of repetitive responses. During investor presentations, companies often referenced artificial intelligence transformation trends associated with leaders like NVIDIA and Microsoft. Internally, however, operational teams described gradual experimentation rather than immediate transformation. This contrast revealed a growing pattern: artificial intelligence messaging focused on future potential, while real deployment remained iterative, cautious, and dependent on organizational readiness. As artificial intelligence pilots expanded, the technology team compared their internal systems with cloud platforms from Amazon Web Services and Microsoft Azure. Processing costs rose quickly, and experiments that seemed simple during demos required larger datasets and stronger computing pipelines. Leadership realized that artificial intelligence was not only software innovation but also infrastructure investment, forcing a slower and more strategic rollout. In financial reporting workflows influenced by automation trends from IBM, analysts tested artificial intelligence systems for document classification and forecasting support. The tools reduced manual sorting time, yet final approvals still required human verification. Managers observed that artificial intelligence improved speed but not accountability. This reinforced the idea that automation was assisting expertise rather than replacing professional responsibility. Inspired by transformation narratives surrounding Google and Microsoft, the company launched internal artificial intelligence training sessions. Employees quickly learned how to generate summaries and automate small workflows. However, deeper integration required understanding data structure and process logic. The organization realized that tools alone were not enough. Practical adoption depended on continuous workforce adaptation. Quarterly discussions began referencing artificial intelligence growth stories tied to companies like NVIDIA and Meta Platforms. Investors expected clear artificial intelligence strategies, pushing executives to communicate progress publicly. Internally, teams were still experimenting. This created a narrative gap where messaging emphasized acceleration, while operational deployment continued at a controlled pace. After months of experimentation, leadership shifted focus from artificial intelligence announcements to workflow redesign. Case studies from Amazon influenced discussions about process automation rather than full replacement of roles. The organization concluded that artificial intelligence delivered value when embedded into structured operations. The hype had introduced urgency, but practical implementation required planning, iteration, and measurable outcomes. When teams attempted to connect artificial intelligence tools with existing enterprise software, they studied integration examples from Salesforce and SAP. They discovered that real transformation depended less on the model itself and more on how systems communicated. Artificial intelligence outputs needed structured workflows, and without integration planning, automation remained isolated experiments rather than operational change. While reviewing internal dashboards, engineers compared their datasets with large-scale platforms used by Google and Amazon. They realized that inconsistent and incomplete data reduced artificial intelligence reliability. Predictions varied across departments, forcing teams to clean and reorganize information. The experience showed that artificial intelligence performance depends heavily on data discipline. Design teams began experimenting with generative tools inspired by products from OpenAI and Adobe. Early outputs generated excitement because concepts appeared instantly. Over time, designers noticed that originality still required human direction. Artificial intelligence accelerated brainstorming, but final creative identity remained dependent on human interpretation and refinement. Executives revisited transformation timelines after observing gradual progress across departments. Case discussions referencing Microsoft and IBM emphasized long-term platform evolution rather than rapid disruption. Leaders concluded that artificial intelligence success depended on process maturity and consistent iteration. The narrative shifted from immediate replacement towards sustained operational improvement. Employees who initially feared automation began noticing practical workflow support instead of job elimination. Internal discussions referenced automation journeys from Amazon and Meta platforms. Artificial intelligence tools handled repetitive formatting, summarization, and analysis tasks. Gradually, the workplace conversation moved from uncertainty toward adaptation, reflecting how direct experience often reduces abstract technological fear. Teams noticed that artificial intelligence improved efficiency in measurable ways. Inspired by practices at Google and Microsoft, repetitive tasks like data entry, report generation, and content summarization were handled faster. While the transformation was not dramatic overnight, employees realized that artificial intelligence could free time for higher-value work, creating practical benefits beyond hype. Executives reflected on the gap between public excitement and internal reality. Observing deployment patterns from Amazon and IBM, leaders admitted that headlines overstated immediate impact. True value required patience, integration, and careful monitoring. The lesson was clear: artificial intelligence is a tool for gradual change, not instant revolution. Human resources, finance, and operations teams began sharing insights on artificial intelligence adoption. Departments compared results with peers in large firms like Meta Platforms and SAP. Real benefits appeared uneven but tangible: faster document processing, improved analytics, and reduced repetitive workload. Employees started recognizing that artificial intelligence supports work rather than replaces it entirely. The company decided to adjust its communication strategy. Internally, teams were honest about artificial intelligence limitations, while externally, updates highlighted progress without exaggeration. This approach balanced public perception and operational reality. Inspired by major tech players, they realized that sustainable artificial intelligence adoption is iterative, disciplined, and aligned with strategic goals, rather than following every media hype cycle. As the journey came to an end, the team recognized the truth: hype can capture eyes, but only disciplined execution creates real impact. True transformation arises when humans guide artificial intelligence, integrate it thoughtfully into workflows, and commit to gradual, patient adoption. If you want to see beyond the headlines, understand how artificial intelligence genuinely reshapes industries, and stay ahead of the curve, subscribe now, turn on notifications, and join us in exploring